Thank you very much for having me here. I'll try to explain a bit what I'm trying to do with this kind of analysis I'm doing. So the idea is to go through very well known, not just buildings of heritage, but also quite well known also restorations and maintenance intervention, which has been doing in the last 10 and 20 years, and trying to giving a reading of it, considering the results that we have after a certain amount of time. Considering the time we have here at disposal, I chose one, which you see here in the short description. It's extremely famous because it won the Domocomo prize for conservation projects in 2021, and it's the restoration of the Zarzuela hippodrome in Madrid, in the next by the capital, the Spanish capital, which has been restored by a team which was won a competition from 2003 with the architectural studio Junquera, together with the engineering studio CFSSL. And as you see here, the project, the original building, is the masterpiece of the engineer Eduardo Torroja, together with a duo of architect Carlos Arniches Moltó and Martín Domínguez Esteban. The building has a complex history of construction because it started during the Civil War, just a couple of months before, and the construction stopped during the Civil War because of a bombing. Also, part of it has been destroyed during the battle for the city of Madrid along the river, and also the work has been done on it for the refurbishment has something to do with this occasion. So as we said, work started in 35 and actually just finished in 31. It's a complex system of grandstands for hippodrome. Let's say when the Spanish state started to get interested in preserving this kind of buildings and creating a system of listing this patrimony, this heritage, they developed a very interesting way of doing it. I mean, in a political and economical way, which I think, besides the technical rehabilitation that we're going to look together right now, it's an interesting case study by itself. So here we see a picture that has been taken in 2008. It's the South Canopy, one of the three of them. It's easy to see it's not devastating state, but still pretty damaged. The top part of the building, which is covering the audience, and let's say why did this happen? Because even if already in the 80s, the canopy itself, just the canopy, was officially listed as a heritage monument, the building was not in use anymore, and was let's say partially abandoned, and I'm sorry. So it needed somehow an idea in order to make it possible to live again and to be renovated. So this opportunity comes slowly. I'm trying to give you the story of how this building was listed, because it's part of the growing interest for the building, also the way it has been assessed and understood before the actual work started of it. So it became in 2009 un Bienes de Interés Cultural de la Ciudad de Madrid. So both for the city and both for the autonomous region of Madrid, and also got onto the protection of the Instituto del Patrimonio Cultural de España. This means that all of, let's say, on every level in the Spanish country, the building became part of, let's say, interest. So in 2003, I got an international competition in order to have a project to renovate the building. And as a first part, they decided that, let's say, the objectives, and as in any project, the first moments are the most important, because it's there where you actually, with the minimal effort, you can make the biggest changes. So they tried to push for a minimal intervention. So avoid, where possible, to replace the original material concrete with invasive process, and reprofiling are discarded from the start, and they proceed instead with patch repair that goes to act on a discrete way only in those points where the process of damage was completely irreversible. Um, very, very fast, just in the drawings you see on the left side the whole compound of the hippodrome, and where my mouse is you can see the building itself. And here on the right side we see one of the grandstand, the west elevation. We see the complexity of the structure, which is organized on tree level, and we are gonna bring it down through this cross section over here a bit to understand how this building was conceived by Torroja before analyzing the restoration. So the load-bearing structure is organized using a repeating module every 4.80 meters along the longitudinal axis of the building. And the spacing is marked by this element, which he calls portico, which is a concrete frame which is cast in situ. And the structural scheme is very clear. It's characterized by this possibility of phasing the construction. So it's designed to facilitate the building process. And you will see this, the main element is this variable section pillar, which is called estibite, which is stabilized transversely by this inclined beam, which is actually supporting the seating stands. And as you see in the picture nearby, there is a set of beams which actually connects the lower part under earth. And on this pillar rests all the the articulate joint that you see in the drawing of the rebar. In the following section, we go further, moving the section to what is actually the most important part of the building, which is this very thin shells, which makes it possible to cover these big distances with this cantilever system. So the space between the portico is covered by this sequence of double curve shells, which has the very thin thickness in the minimum part, which is around 5 centimeters. And as you can see, the first shell covers the underneath gallery where the people comes in. And you have then the second shell, which is covering from the upper side the people who is watching the stadio, and the third shell is hanging down through this 10 style element. Each model of the canopy measures about 5 meters in width and 30 meters in length. And as we said, it changes its section because it's composed through 2 hyperboloids and 1 conoid, and the membrane is characterized by a very thin section. And this is going to be very important in understanding where the biggest damage has been done by the water, because this V-shaped section creates a gutter in the middle, and the deflection change is very harsh on the length of this element. So from 1.5 meter at the maximum where the support is to 1.5 where it's actually in the maximum moment in the span on where the overhang is. Talking about the concrete, as you can see in this picture, which has been taken during the construction, it seems, at least at the beginning, that it was conceived to having a very smooth and strong texture of exposed concrete because it was poured in situ. We see, in fact, the result of the formwork, this male-female jointed system that for planks, which has been used to make it possible to create this ribbed geometry for the surfaces and to reuse the planks in order to create an economy of scale in the construction of the building. Through the analysis of the CEDEX, which is the Centro de Experimentación de Obras Públicas in Spain, we know that actually the quality of the concrete, considering it's in the 30s, it's pretty good. Still a bit porous because not the share of Portland cement in the mixture was not so high, and this is gonna, let's say, influence the work on the building. Maybe this is not so well known, but when one looks at the construction pictures, it imagines that the original building would have been in exposed concrete, because those are the picture which mostly have been shared. But actually, already immediately after the construction, in the publication of 1941, which was curated by the architect and Torroja himself, the building is shown with its actual finishing, so with this waterproof painting in white, which was the actual image of the building when it was finished. So we were talking about the whole evolution of things which happened before the actual start of the work of the intervention of the building, and the diagnostic, the assessment in this case has been very long, because we have a first period between 1999 and 2000 where some of the most important institutions in Spain regarding architecture and public buildings make their first studies on it, which then continue with the first stages of the restoration itself, and continues till today, after the finish, the end of the work on the building, thanks to the Instituto Torroja, which has using a very advanced system of sensor in order to monitor the evolution of the corrosion of the rebar and the condition of the moisture in the inner part of the shells itself. Let's say, what were the problem of the building when they started to think of the restoration? It was certainly to say that the external agents and the maintenance negligence were one of the big problem, and on the other side, the intrinsic cause of the natural aging process of concrete, the inefficiency of the waterproofing and drainage system on the extrados of the shell, due to the obsolescence of the materials used and the lack of maintenance. The saturation of liquid water in the extrados, combined with the anaerobic protective action of the bituminous membrane, had on one side the positive effect of slowing down the carbonation front of the concrete, which was good on the upper side of the building. But however, this didn't happen properly on the bottom part, which where the paint did not provide this kind of protection, making the carbonation on this part high, very much stronger. So if the average penetration of carbonation was 60 millimeters, in the peaks point, which is next to the supports, it was almost 120, reaching to the second layer of the rebar. And it's really in these points where we have the strongest damages, where the really conical section of concrete in the most delicate part of the building completely detached. So not just spalling, but really getting dangerous in a structural way. So this percolation of water due to the damage on the upper part, on the other side, accelerated the corrosion phenomena on the top part. Anyhow, we can say, considering the quality of the concrete and the fact that for almost 70 years, the age of the building and the low maintenance, the situation was not extremely critical when the work started on the building. In these pictures, which to me are really talking, shows us what we could find back then. So this aluminium corrugated membrane, which has been partially destroyed simply by the sun and the rain, which completely eliminated. So the first move that the architects and the engineers decided to was to practicate a demolition which was selective. So in order to very delicately understand how to go on with the processes, they started to remove the covering, the waterproofing finishes, with a pressuring bar, not too high, 900 to 1,200 bars. This made it possible to have the concrete exposed after 1943 for the first time. So to see once again the concrete of the construction, and then they got further in the point where the concrete was the most damaged, with a way stronger pressure, with 2,000 bar, and eliminated all of the rotten concrete, let's say, in the position where the spalling and the delamination was the strongest. After this, in a very traditional way, let's say, they started to um, wipe wire with a brush to clean the rebar and to remove the oxide parts, and then the products were applied as a passivator and primer for the application of mortar and cement-based epoxy resin containing the corrosion inhibitors. They did not use any corrosion inhibitors outside let's say, the concrete which has been applied itself, or active cathodic system of any kind. For the volumetric restoration itself, of the concrete surface, they used the thixotropic cement-based mortars, and depending on the how thick it used to be, it was either one component repair mortar enriched with silica fume and fine grained polymers, or in the case it was thicker, the R3, the structural one type mortar for high thickness application, which is fiber reinforced. The next, let's say, step has been the one of protecting this new constituted surface of concrete, and so they have been applying a 2.5 or 5 millimeter thick cover with acrylic paint in white, which would prevent CO2 to permeate and to attack the surface of the concrete. At the same point, this spraying had also water repellent properties. The most interesting part is for sure what happened on the extrados and not on the intrados of the building, because here the damage under the water protection were stronger. And what they needed to do was to prevent the thermal expansion of this and also the movements of this canopy, which, because it's so light and so highly influenced by the movement of the people on the in the down let's say in the ground level of the building. They needed to create a system that would be capable of resist to the elastic deformation, the movements of the building, and be capable at the same time to maintain its protective action. So after removing the bituminous membrane, the concrete of the canopy was, let's say, covered with a thin layer of mortar, which was divided in square sections, and these square sections were connected through a synthetic rubber, EPDM, so ethylene and propylene DN monomer, which could give this elasticity to this layer that they applied on the top of the building. And on top of this, afterwards, they applied then a polyurethane membrane with a thickness or 2 or 3 centimeters, because, as we said, the surface was not so even, so they needed to be a bit flexible on this. They didn't use any product to protect the surface furthermore from a natural origin like mousse or graffiti, so that there was no need for this kind of appliance against moisture colonization. The other steps that they needed to take were more linked to the structural part of the building. So one of the main problems, as we said, partially because of the bombings of 36, but also partially because simply of the movements of these big wings on the top of the building, was a series of cracks that the designer of the restoration project actually thought that would have been connected, these cracks on the top and on the bottom, from the extrados to the intrados of the shells, which actually was not the case. So they could fix it simply with this resin, epoxy resin, in 2 components that you see here in this picture, the preparation. So they would cut into the cracks to make it possible to refill it through pressure. They would insert cannulas that you see here in this picture within the cracks, and then inject the resin to seal them. After this would harden, they would remove the plastic cannulas, and then simply with air 3 concrete, they would recreate the smooth surface of the original concrete. What you see here is a series of other impressive structural intervention they need to do. The tie rod on the back part of the shell, which actually sustains the torus shaped shell, which covers the main entrance, was completely corroded internally. And so they needed to remove the asbeton cover that was used as a formwork, loose formwork, and take out the original rebar, polish it completely, and then create ex novo a new, this time wood fiber reinforced concrete shelter, let's say, for the rebar that was hidden inside. You can see the whole process through these pictures. Also, when they started to do the project, they thought that the drawings that we received would be the same of the actual construction of the building, but it came out that during the war, because of lack of material, the foundation were built way smaller than it was what it was drawn by Torroja in the original plans of construction. So in order to make it secure for today's security norms for public spaces, they needed to do extremely heavy intervention for the foundation, which absorbed the most part of the budget which was available for this work, which was at the beginning around 8 million and reached 11 millions at the end of the work. Here you see some picture which has been taken by me in 2023. So we said that 2015, it's the end of the restoration. It's almost 1 decade, and the building has not undergone any further intervention since then. And we can see that the canopies and also the grandstands remain in excellent condition, and the data which has been collected by the sensor we have been mentioning before by the Torroja Institute, which are both about the state of corrosion and of the rebar, and both of the humidity which penetrated into the concrete. So this shows us the efficiency of the new layer that has been implemented, confirm that the waterproofing is working and it's effective, and it's preventing the saturation of the structure. We can see that maybe one can say that there's some discoloration are visible, some biological colonization, which maybe are depending by the fact that this area are a bit more exposed to rainwater because they are at the edge of the canopy, or maybe because they haven't been used products to protect the concrete by this kind of effects. But one has to say that this gives to the final perception of the building a roughness maybe that would be completely destroyed by this plastic effect that this kind of protection would give. It's way better, as the architects say themselves, to implement a plan of not extraordinary but ordinary conservation of the building. And this has been developed by the architects within the project, and has been possible, I think, because of the very good economical structure of the project itself. So what I want to say is, to have an effective restoration of a building is not just the technical part, which is necessary, but the whole system beneath. Because having this joint venture of public and private, you have on one side assurance that the high quality of the public institution and attention that has been given of the historical part and the technical part, but at the same part, the economical flow to make it work as a public space, but that has to relate to private interest, makes it possible to have a really good maintenance of the buildings. And the Elena Pascual Sanz, which has been following the project for Junqueras and which I've been interviewed, she's convinced that actually with this kind of conservation plan they have implemented, the building could stay in a useful life for other 50 or 70 years, which is pretty impressive in my opinion. One has to be said even more that the success of this conservation is once again, in my opinion, due to the economical and political frame. On the second hand, by the quality of the projects, the assessments that have been done, and actually the application of the work itself. But also has to be mentioned the climate of Madrid, which is really dry, which makes it easier for such a building to keep in form. The quality of the building itself, both in geometrical terms and the quality of the concrete, which in many cases is bad. This concrete from the 30s of Torroja, in terms of porosity and compression resistance, is better than many examples we have from the 60s and 70s. And for example, buildings, heritage buildings that we have in Italy, in Rome or in Turin, where the quality of the concrete, unluckily, is not as good as the one of the hippodrome of the Zarzuela. Thank you.